A stone is fired vertically upwards from a catapult with an initial speed of 10 meters per second. Find the time for which the ball is 5 meters above the point of release. Let's visualize what's happening here. Stone's fired vertically upwards. It will slow down to 0 eventually and fall back to earth like this. Fired with an initial speed of 10 meters per second. We can call that the positive direction. But remember, the acceleration will be in the opposite direction initially. And we'll call this the negative direction. And let's say this is 5 meters above ground level. So we can see that the ball passes 5 meters on its way up and then again on its way down. And the question's asking us the time for which the ball is on that upper part of the journey. Let's look at the information we know. We have S, the displacement, is 5 meters, and we want to know the time when the ball is at 5 meters on the way up and also on the way down. We know the initial speed is 10 meters per second, and we know that the acceleration is minus g, which equals minus 9.8 meters per second squared. This suggests the best equation to use is S equals ut plus a half at squared, because we have all the relevant information. Plugging the values in, we get 5 equals 10t minus a half 9.8 t squared, where t is the time since the ball was thrown up. Rearranging this, we obtain the quadratic equation 4.9 t squared minus 10 t plus 5 equals 0. We can solve this with the quadratic formula, and that will lead to t being equals to 10 plus or minus square root of 2 divided by 9.8, which gives us the two values of t as 0.876 and 1.165. Two values because we have a quadratic equation, and we expect two values because the ball reaches 5 meters on its way up and also on its way down. So to answer the question, the final time interval is going to be the difference between these two times. 1.165 seconds minus 0.876, which gives us 0.289 seconds.